Okay, good. Now we're going to use a formula to define what a function is. That's what we're going to do now. Okay? All right. So here the idea with the formula is you'll have f of x will equal to some algebraic expression in x. And the idea here is that you're going to replace x by numbers, and your f of x will give you the corresponding output. Your f of x will give us the corresponding output. So here are just some examples. For instance, let's say we wanted to get f of 2 and f of negative 1. So what is this saying? This is saying replace x by 2 in our function, which in this case is 8x plus 9. Okay. And so what would f of 2 be? Well, we have to replace x by 2 and evaluate it. So we replace x by 2, right? And we evaluate it. Doing so, what do we get? Well, 8 times 2 we know is 16. Then we're adding 9. So we have 8 times 2 plus 9, which is 16 plus 9, which is 25. So this is saying that f of 2 is 25. So when x is 2, we get 25 back. F of negative 1, same idea. Except instead of replacing x by 2, you're replacing x by negative 1. So f of negative 1 is this. 8 times negative 1 plus 9. Well, this is the same as negative 8 plus 9, which is 1. So f of negative 1 is 1. So when x is negative 1, you plug it in for x, your input, the output you get is 1. We have this kind of function. So that's a formula. This is evaluating a function at numbers. Now, in the next example, we want to find x, okay, so that f of x is 2. So in this case, we're solving an equation. That is, we're solving an equation involving a function, We're solving an equation involving a function. We want to know when f of x is 2. Well, what is f of x? We have our formula. So we want to know when, by substituting, 8x plus 9 is 2. We want x so that this equation holds. How are we going to pull that off? We're going to use some basic algebra. That's what I'm doing here. Right? So again, you want to isolate x. You're solving an equation. So what I'm doing is this. We have 9 here. Well, let's get the 9 out of there by subtracting. Right? 9's gone. We have negative 7. So we have 8x is negative 7. We don't want 8x, though. We want x. So what do? We're dividing. And we get x is negative 7 over 8. Negative 7 over 8. So in other words, what we have then is when x is negative 7 over 8, f of that is going to give us 2. Okay, that's good. Let's do another one. Okay. So here's another example, okay? In this example, f of x is defined a little bit differently. Namely here, f of x is negative 8 times x plus 9. So before we had, let me see if I can get it, we had 8x plus 9, but here we have negative 8x plus 9. So let's evaluate f of 2 and f of negative 1. It's the same idea. F of x is defined by a formula. We have f of 2 is negative 8 times 2 plus 9. So we're evaluating the function. We're seeing what happens when x is replaced by 2. And we get this. Excuse me. Here, we're doing f of -1. It's just like the previous, well, similar to the previous example. We're replacing x with -1, and we're seeing what happens. Well, you get -8 times -1 plus 9 is 17. So again, this is our function. This is what's taking in x's input and giving back our output. And we just did some examples. Now for the next one, we're going to determine when f of x is 5. So we want to know, when does this happen? In other words, what value of x will make f of x equal to 5? When is this equation going to hold? That's what we want to know. Okay,